Hey there, and welcome. So, we're going to tackle a huge puzzle in nature today. We usually think of competition as this brutal winner-take-all fight. But what if I told you that constant struggle is actually the secret ingredient that creates the incredible variety of life we see everywhere? Yeah, pretty cool, right? Let's get into it. So, let's start with a really basic question. Imagine two species fighting for the exact same food, the same patch of land, the whole shebang. Can they actually coexist? Or is one of them always just doomed to disappear? That's the core problem we're going to unpack.
For a really long time, science had a pretty harsh answer to that question, and it was all based on this fundamental rule of conflict over resources.
And that rule has a name, the Competitive Exclusion Principle, sometimes called Gause's Law. It's a huge deal in ecology, and it basically says this. If two species need the exact same stuff to survive, one of them will always, and I mean always, be a little bit better at getting it. Maybe a tiny bit faster or more efficient. And you know what? That tiny edge is all it takes.
The principle is absolutely ruthless. Over time, that slightly better competitor is going to take over everything. And the other one? Well, it gets pushed out completely. It's the ultimate winner-takes-all situation.
Now, this isn't just some abstract idea. It was proven crystal clear in a brilliant and really simple lab experiment, a real showdown.
Okay, so back in the 1930s, this biologist, G.F. Gause, decided to test this whole idea. He took two tiny little protists, two different species of paramecium. Just think of them as two microscopic gladiators entering the arena of a petri dish. His setup was genius in its simplicity. First, he grew each species in its own little jar. And guess what? They both did great. They grew and grew until they basically filled up their little worlds. But then, he put them in the same jar with the same limited amount of food. And suddenly, the competition was on. The result? Whoa, it was dramatic and totally clear. One species, Paramecium aurelia, was just a better competitor. Its population exploded. And the other one, Paramecium caudatum, its numbers just crashed until, eventually, there were none left. Wiped out.
Gauss's big takeaway from this became one of the most famous lines in all of ecology. Complete competitors cannot coexist. He had proved his point, no doubt about it.
Okay, but wait a second. This raises a massive question, right? If this rule is so ironclad, why isn't the planet just dominated by a handful of super species? I mean, look around you. Forests, oceans, jungles. They're absolutely bursting with thousands of different species, and a lot of them seem to be competing. So, how is that even possible?
Well, it turns out that nature is way, way cleverer than a petri dish. Over millions of years, species have figured out these incredible strategies to avoid the fate of Gause's poor little paramecium. They found escape routes.
And these escape routes usually follow one of two main paths. The first is kind of a quick fix, a behavioral change called resource partitioning. The second is the long game, an evolutionary fix we call character displacement. Let's break down exactly what those mean.
All right, so let's dig into these two paths. One is about changing what you do, and the other is about changing who you are. So first up, we have resource partitioning. You can think of this as species basically agreeing to disagree. They figure out how to share by using different parts of a resource, or maybe using it at different times of day. It's a behavioral workaround.
The textbook example of this is a famous study on warblers. A scientist found 5 different species of these little birds all living and eating insects in the very same trees. How did they do it? They split up the tree. The Cape May warbler hunted for bugs at the tippy top, the Blackburnian warbler stuck to the upper middle branches, and others took the lower sections. They each carved out their own little mini territory, neatly avoiding a food fight.
Now, the second strategy is way more permanent. This is character displacement. And it's not just about changing your habits. It's about the competition literally changing your body over generations. It's evolution in action. And for this, we go to Darwin's famous finches in the Galapagos. Here's what happens. When a finch species lives on an island all by itself, we call that allopatry, their beaks are kind of all-purpose tools, good for lots of different seeds. But when two species end up on the same island, that sympatry, something incredible happens. Their beak sizes actually move apart. One species evolves a smaller, delicate beak for tiny seeds, while the other evolves a big, powerful beak for cracking tough nuts. They literally evolve away from each other to stay out of each other's way. So let's just put these two side by side to make it super clear. Think of resource partitioning as a software update. It's a fast behavioral change. The warblers didn't change their beaks, they changed how they use the tree. It can happen really fast. Character displacement, on the other hand, is a hardware upgrade. It's a slow, physical, evolutionary change to the species itself, passed down over generations. So one is about changing your actions, the other is about changing your actual body.
And the coolest part? This isn't just a theory we pieced together from fossils. We have actually watched this creative force of competition happen right before our eyes.
On the island of Daphne Major, scientists saw it happen with those very finches. For years, one species, G. fortis, owned the place. But then, in 2004, a bigger, tougher competitor arrived. A year later, a drought hit, and only large, hard seeds were left. The big new finch had a huge advantage. So what happened to the original finches? Their population evolved. In just a couple of generations, their average beak size actually shrank, which allowed them to become experts at eating the tiny seeds the big guys were ignoring. That is literally character displacement caught on camera. And that really brings us to the big idea here. That competitive exclusion principle, the winner-takes-all rule, it sets the stage, but it's not the final act. It's the constant pressure to avoid that fate that becomes one of the most powerful, creative forces in evolution, pushing species to become different and creating the amazing biodiversity we see all over our planet.
So I'll leave you with this to chew on. Maybe we've been looking at competition all wrong. What if it's less about a brutal battle for survival and much, much more about being the engine of creation itself? Pretty wild to think about. Thanks for joining me.